All right, let's try to finish up that lesson that we started yesterday. I got an example to do and then another theorem. That other theorem is pretty simple. That shouldn't take too long. I just want to get this example done. Just didn't quite have time yesterday to do it. So let's draw a parallelogram. And I'm going to twist it, and I'm going to tilt it a little bit. Let's see, maybe about like that. I'm going to tilt it like this. And I'll change the angle a little bit. Yeah, that's pretty good. So that looks pretty close. All right. So let's name it. This is J. This is K, L, and M. All right. All right, so they put some stuff in here, so let's put some stuff in here. This is 7a degrees. 7a degrees. This is 13a degrees. This is, I'll tell you what. Yeah, we'll just do it all in red, doesn't matter. So this is 2x. This is x. This is 2y plus 1. Oh, one more thing. 5y minus 2. All right, there it is. So guess what we have to solve for? Solve for everything. All right, let's solve for all the sides, the missing sides, and let's solve for all the missing angles. Yep, that's basically what they're asking you to do. Let me push all this over a little bit. Give me some room to write over here. All right. So what did we learn yesterday? Now this, I thought I made this kind of slanted looking. Oh, you know what I should have done? I should have done this. This is what I wanted to do, I think. Let me see. Nope, it's not what I wanted to do. I'll keep it like that. It doesn't matter. I was trying to make this a little bit slanty. This kind of looks like a rectangle, doesn't it? All right, I was trying to make it not look like a rectangle. You're eating in my room? You're like a scholar? I'm interactive and I understand. You are. You don't ever give me any trouble. You're right, but don't make this a habit. Okay, I got you. All right, because it's one of my pet peeves, people eating in my room. All right. All right, I'll try not to. All right, so let's see. What are we going to do first? You can do the angles first? Let's do the angles first. I think the angles are a little bit easier. So what are we going to do here? I got this angle. I got this angle. Don't know that one. Don't know that one. So if this is a parallelogram, which they tell you it is, okay, so they start off, I should have said that. This is a parallelogram, they tell you. So they say parallelogram, JKLM. JKLM. All right, so it's a parallelogram. So what do you know about stuff as it's a parallelogram? What do you know about the opposite sides? They're equal to each other, okay? They're parallel to each other. What do you know about the opposite angles? Opposite angles are equal to each other. What else do we know about the angles? We know the opposite angles are equal to each other, but that doesn't really help me here, does it? Because, yeah, these angles right here, the consecutive angles, what are they? Supplementary, that's right. So that's what we're going to do first. Everybody good with that? So, how are we going to write that down? 13a, what? Plus 7a, what does it equal? 180, right, because they're supplementary. Everybody got that? So this angle right here and this angle right here are supplementary. Of course, you could have done these two up here because that's also 13a, isn't it? Because remember, the opposite angles are equal to each other. This is also 7a down here, but we don't really need those. You just need these two right here, and now you can solve for a. So what's that? 20a equals 180 divided by 20. A is, what's that? 9. Okay, does that mean the angle is 9 degrees? No, it just means A is 9. So if I wanted to find an angle J is what? 7a, isn't it? Or 7 times 9, which is 63. Now, is that in degrees? Absolutely, because that's the value of that angle right there. Okay, so this angle right here is 63 degrees. Again, doesn't look like it. I tried to make it look like it, but I don't know. I guess I could if I tried a little harder, but that's what that is. Now, you could solve for this angle down here, angle M, a couple different ways. What do you think the easiest way to solve that would be? That's what I would do. I would probably just go 180 minus 63, wouldn't you? That's what, 117? You could. Yes. You could go 13 times 9. Yep. And you get the same exact thing. Try it. 13 times 9, and it will be 117. So that means that angle M is 117. Now, the other two missing angles are super easy. You don't even have to do any math, do you? What's angle K going to be? What is it? 117, yes. Okay, and what's angle L going to be? 63. Yep. So once you get the two of them, the other ones are easy because remember, the opposite angles are equal to each other on a parallelogram. All right, good. We got the angles. Now what do we have to solve for? All the sides, that's right. Now the math on this, well, let's set it up first, then we'll talk about the math on it, okay? The math is a little bit trickier than you're probably used to, but if you had a decent Algebra 1 class, it shouldn't be difficult for you. So, what do we know? We said this right off the bat. What do we know about the opposite sides of a parallelogram? They're equal to each other. So, guess what we're going to do? We're going to set them equal. So, I'll tell you what. Let's do this one first, okay? So, this x is equal to what? 2y plus 1. Now, if that's all the information I had, would I be able to solve for x and y here? Not, because I got two variables. I don't know if you heard this before, but in algebra, when I teach this, I always say if you have two variables, you need two equations to be able to solve for those two variables, okay? You can't just solve for two variables with one equation. You need a second equation. All right, so what's our second equation going to be? 2x equals 5y minus 2. Good. Because these two right here. All right, so they're across from each other. They're equal. These are across from each other. They're equal. And now we should be able to solve for x and y. So the math, again, is a little bit more complicated. Not much. Not for you guys, because you guys are scholars, right? Okay. All right. So what do you think you're going to do? What math are you going to do to solve for x and y? Sure you are. You all are scholars. Well, this is kind of what x is equal to, isn't it? So what's x equal to? 2y plus 1. Very good. I like that word. That is a scholarly word. So you're gonna take what x is equal to, and you're gonna put it in. You're gonna substitute it, right? That's the word she used. You're gonna substitute it in for this x right there, because this x up here and this x down here represent the same x, the same number, right? Same thing with the y's. So if x is equal to this, watch what we can do. So this is 2x, or 2 times what? What's x equal to? 2y plus 1, that's right. So I could put 2y plus 1 right there. Everybody see that? That's substitution. Did you guys do that in Algebra 1? Substitution, elimination? Did you do elimination? Okay. Because of this equation. See, this 2x equals 5y minus 2. So this is 2 times x. This thing right here in parentheses is my x. Agreed? And now we can just write the rest of this bottom equation out. Equals what? 5y minus 2. Now check it out. Look, I got one equation with how many variables? Well, No. When I say how many variables, not how many times does it show up, but there's just one letter, right? There's one letter, and it's y. Would you agree? I mean, there's y here and there's y here, but there's only one variable. All right, so I got one equation, one variable. Now I should be able to solve for y. Once I get y, then guess what I can do? Plug it in for this y right here, right? 2 times whatever y is plus 1, and that gives me my x. Then I'm good to go. Then I can find all 4 of those sides. We good? All right, let's do some math. Pretty basic. Just distribute the 2, so I get 4y plus 2 equals 5y minus 2. Let's put the y on the right-hand side just to make it positive. So I'm going to subtract a 4y from both sides. And let's take this minus 2, put it over to the left side. I'm going to do that by adding a 2. All right, so that cancels. I get a 4 here. That cancels. 5y minus 4y is 1y, or we could just write it y equals 4. So we're about halfway done, right? Now we got a little bit more than halfway, but we got what y is equal to. Now, let's solve for x. How do I solve for x? Well, I put that y. Sure. Well, I need to know this side right here. That is true. You are right on that. Okay, so you could just find that and say that's the same. You could find this and say that's the same. That's true. But for fun, let's solve for x. All right? But you are correct. So you are a scholar now. All right, so x equals what? 2 times 4 plus 1. So x equals 8 plus 1 is 9. We good? All right. So like Samara said, if all you knew was y, that'd be okay because you could always find the other side. So let's do this. Can we do this in our head? 5 times y, 5 times what? 4, which is 20, minus 2 is 18. So that's 18. All right, so what's this side right here? JM. It's also 18 without even knowing what x is. But let's just see. We found x, right? Let's use it and see if it actually works. 2 times x, or what? 2 times 9? Yep, it is 18. It works, doesn't it? All right, what about this one? 2y plus 1. So 2 times 9, which is 18, plus 1 is... That's right. I was just checking to see if you were paying attention. 2 times y, 2 times 4, which is 8, plus 1 is 9. All right, so this side right here is 9. And is x equal to 9? Yes, it is. Everything works out nice and perfect, beautiful. And there you go. You found all the missing sides and missing angles. We good? Yeah. Really, the only geometry, what was the only geometry here? The only geometry is to understand that the 2 consecutive angles are supplementary, correct? And that the opposite angles are equal to each other. What was your other part of the geometry? It was just to understand that the opposite sides are equal to each other. So really, that was all the geometry that was involved. But as you can see, a little more complicated when you put variables in there. But the geometry was pretty simple. Yes? All right. Let's move on. Let's do this. You've seen stuff like this. Let me do this. Copy, paste. You've seen stuff like this before. But we're going to do something a little bit different than what we did before. What do you think might possibly be true about these 3 lines? The first 3 lines that I drew. They're what? Congruent? They're lines. They keep on going. I didn't put the arrows on there, but so they're not congruent. They're what? Parallel. Okay, so this, and this are parallel. Everybody okay with that? All right. Let's label this a little bit. J, K, and L. Call that J. Call that K. Call that L. What is the J? It's that point, right, where they intersect each other. The K and the L. Yes? And this is P. This is Q. And this is R. All right. And so here's what the theorem says. Okay, it's only one theorem. It's pretty simple. not really going to do like an official example or anything for it, but it's pretty basic. Here's what the theorem says. I'm not going to write it down, but I'm going to read it to you. So listen while I read it. It says, if three or more parallel lines, do I have that here? Yes. If three or more parallel lines divide a transversal into congruent segments. Actually, I did not draw it correctly. I should have put it right in the middle. Which one should I move? Let's move this one. Transversal means it cuts the parallel lines. It's another line that cuts the parallel lines. Say what? This is a theorem, correct? Oops. Let's just get rid of this. And let's get rid of that, get rid of that. I should have made it look a little bit more to scale. And that's what I'm trying to do right now, okay? So here's what it says. There's three or more parallel lines divide a transversal into congruent segments. So let's say these three lines divide this line right here. Okay, this left one, okay, that's transversal, right? Because it cuts the three lines. If it cuts it into equal or congruent segments, that means that this one and this one are congruent to each other. All right, they told me that. They said that that was true. Everybody with me? Okay. So if these three lines divide this transversal into two equal segments, so if this segment is equal to this segment, take a wild guess on what might possibly be true about PQ and QR. They're also going to be equal. Does it mean that they're necessarily equal to this segment? No, but these two would be equal to each other. So for instance, if I said that was 3 and that was 3, okay, and I told you this was 5, then what could you say about QR? That's also going to be 5. Everybody with me on that? Okay, so if these two are equal, these two are equal. It doesn't mean they're equal to each other, right? It doesn't mean that these two are equal to these two. But if these two are equal to each other, then these two right here are equal to each other. There are situations where it could happen, but not every situation, all right? But you are right. There are situations where this might be 3 as well. So if this was 3 as well, but it doesn't mean, just because these two are equal to each other does not mean that they're both the same as these two. We got it? Yeah, and that's it. So basically it says this. It says if JK is equal to KL, then what do you think is true over here? Let's use letters. So if JK equals KL, then what do you think? PQ equals QR. Very good. Then PQ equals QR. This means the length of, all right? It's pretty easy, isn't it? Yeah. All right. That's it for section 6.2. They give it a name too, but they call it, I don't know, it's a wordy name, so I would never remember it. It's called the congruent division of transversals theorem.
Wait, so just the answer would be if JK equals KL, then
Well, it's not really an answer, but that's what the theorem tells us. That's basically what the theorem, that in a nutshell right there is what the theorem says.
how would it work if we had all?
Well, like I did right here. If I said this one and this one are both 3, and this one was 5, tell me what that one is. It's 5, okay? And they could put letters in here too, right? X plus 2, 3x minus 7, you know, stuff like that. And then you could set things equal to each other. You could solve for x, you could plug it back in, right? Just like we did on the other one, okay? So they could make it more complicated for sure. But this is the basic idea of what this theorem tells us. Yep. Yeah, I mean, they could say that this one was equal to this one, so this might be like 3x plus 2, and this might be 2x minus 7, right? And then so what do? You set these equal to each other, solve for x, so you could find the lengths of both of these. Make sense?
What if they ask you to find P?
They could ask you to, well, p, if they just say p is just a point. There's nothing really to solve for if you just solve for P. They could ask for PR though, couldn't they? Right? Like if I did that 5 and 5 thing, what is PR? What? Line segment PR? What is the line segment? What if this was 5 and this was 5? Okay, that would be 10, right? Not that hard. All right, so not 180, not asking for degrees, just asking for the length of the line segment. I doubt on these they will. But you could, I mean, they could, I guess, because look, this angle and this angle are what to each other? They're equal, okay? Because parallel lines cut by transversal, these are, trying to think of the word. I can't think of the word now. Not consecutive. No, they're not adjacent. They're corresponding. I knew it started with a C. They're corresponding angles. Same thing with this angle right here. Agreed? Say what? They will be. And it's not really because of this theorem. It's just because we already know that when you have two lines, or two parallel lines cut by transversal, we know the corresponding angles are equal to each other. All right, so that's really nothing new. But I mean, I don't know if they do or not, but they could, give you this angle and ask for this angle or something like that. All right, we good? Good. So your homework, this is official now. So it's section 6.2. It's just going to be one section. It's not going to be an A or a B. All right? Everybody hearing me? A lot of distraction. 260, we're doing 1 through 17. Did any of you guys try these last night? Yeah, I think I told you. Go ahead and try them because I'm going to assign them. All right? Might as well get them done as much as you can. Were you able to do all of these with the stuff we did yesterday? Okay. So this is probably the newer stuff, the 21 to 24. All right, so I'll let you work on that. You got about 25 minutes, okay, to work on that. Get it all done, then you won't have any homework to do in math anyway. And then we'll turn that in tomorrow, and we'll move on to the next section, section 6.3. Everybody good? Okay.